The fact that black holes exist, I think, the gravitationally completely collapsed objects that distort space and time so much that even light can't escape. I still think it's mind-blowing that according to Einstein's theory alone, time ends inside a black hole. I'm Brian Cox, and I am here to answer questions from the Honesty Box. Explain quantum mechanics to a child. So quantum mechanics is the base theory, we think. I think people tend to think of quantum mechanics as something that applies to atoms and electrons and particles, but not to us. And that's not right. So quantum mechanics is the theory that describes everything. The point is, though, it produces, when you look at big things, it produces behavior which can be more accurately or more usefully, not more accurately, but more usefully described by things like Newton's laws. It is necessary to understand quantum mechanics to understand how a transistor works, for example, or how a laser works, or how, of course, a nuclear reactor works, or the sun works. So it's not just a theory that's a theory of little things bouncing around. It's a theory that's necessary to understand a lot of things that we take for granted today. And it's an unusual theory. It's strange because it's got probabilities in it. And that was it was Ernest Rutherford, actually, so famously got the Nobel Prize at Manchester for discovering the atomic nucleus. But he pointed out that in the late 1800s, early 1900s, when we start looking at radioactivity, you see that radioactive decay is a probabilistic process. So it means that given something like a uranium nucleus, you can't tell, even if you made 100 uranium nuclei at the same time, you could just make them, then you can't predict when any one of them is going to decay away and emit some radiation. Basically, it's probabilistic. And so that idea was shocking to people, that it appears that the world is not like Newtonian clockwork. So I would say quantum mechanics, my explanation is it's a weird theory, it's a kind of probability theory, and but it's the way that things actually are. Can you explain the scale of the universe? No. So you can give the numbers. So the nearest large galaxy, Andromeda, is about 2 million light years away, which means light travelling at 300,000 kilometres per second, from our point of view, takes 2 million years to travel from the Andromeda galaxy to us. So if you go away from the city lights and out on a clear sky, and when there's no moon particularly, then you'll be able to see Andromeda if you've got some binoculars, and it's worth looking at, because the light entering your eye began its journey 2 million years ago, which is before we'd evolved on Earth. So that gives you a sense, and you can see that. You can just about see it with the naked eye, because it's big. It's a big galaxy, about 1 trillion stars. And it's actually, although it's very faint, it's bigger than a full moon on the sky, so it's a big thing. I think that's the best explanation of the scale, because you can just about, I think, get your head around that. But that's the nearest galaxy. So when you start talking about galaxies that we see, beautiful images with the Hubble Space Telescope or the JWST, for example, you're looking at things that are 50 million light years away, 300 million light years away for a thing called Stephan's Quintet and onward. And those, 300 million light years. And many of the galaxies we can see in photographs with like the James Webb, for example. Those things are so far away that the light began its journey before the Earth had formed. And that's incomprehensible, I think. So the answer is I can't explain the true scale of the universe or picture it. Is there life on Mars? Don't know, but it's certainly possible. And as we speak, we have several missions out there, but one of them is called Perseverance, which is a rover. And as we're speaking now, it's on the surface of Mars. It's taking samples. It's taken a lot of samples below the ground, and they're being packaged up for return to Earth in something that's called Mars Sample Return, because we think that it's possible that life existed on Mars or may still exist, because the conditions were right. It's certainly true that 4 billion years ago, almost certainly Mars was like Earth. When life began on Earth, Mars was pretty much the same, with oceans and an atmosphere and so on. So it's entirely possible. And it would almost be surprising if it hadn't existed, because then it would tell us that even given the right conditions, then maybe there isn't a high probability that life begins or geology becomes biology or whatever the origin of life is. So possible. Would teleportation work? It does. No, maybe I should say a bit more. So it does, in the sense that, so it's been done with photons, for example, so particles of light. So you can do the experiment where you essentially, it's based on on having two photons that are entangled, quantum entangled together. So the best way to describe that in about a second is that they behave as a single system, basically, but you can separate them. And then you can arrange for another one to come in so it kind of interacts with this one such that it ends up, this one over here, which could be a light year over there, ends up being in the same photon, essentially, as the one that came in, or in the same quantum state. So it's teleportation. And the incoming one gets destroyed in that process, or its state is changed. So yes, we do quantum teleportation in the lab, so it's real. The question then becomes, how big an object can you teleport? And I think in principle, there's no reason why you can't teleport anything, right? But it's very much in principle. What is a wormhole? Are they just science fiction? So no, the first time they came into physics was in 1930, I think it's 1935, in a paper by Einstein and Rosen. So they noticed that the description of the distortion of space-time in the vicinity of a star, which was discovered by Carl Schwarzschild in 1916, they discovered that if you take that description and you allow the star to collapse essentially into a black hole, and then you extend it infinitely into the past. So you say, well, let's imagine this black hole had always existed. So this universe in which this thing exists is an eternal universe. Then you get a wormhole. So a wormhole, the description of it is in the mathematics that Carl Schwarzschild discovered in 1916 for the distortion of space-time around a star. Literally, you have two universes, and they're linked by a wormhole. So one of them is a black hole and the other bit is a white hole. So that's just formally in the mathematics. So that's what a wormhole is in Einstein's theory. That requires this black hole to have existed forever. So, and by the way, if the black hole's spinning, then you kind of get an infinite tower of wormholes. So the so-called Kerr black hole, this was discovered in the 1960s by Roy Kerr, for a spinning black hole. The solution to that, if it's this eternal solution, is that you have an infinite number of universes connected inside the black hole by an infinite number of wormholes. So the modern work on trying to understand what happens to things that fall into black holes might suggest that there's a kind of a wormhole that connects the interior of the black hole to the exterior universe. And so the singularity looks like this kind of network, tangled web of wormholes of some description. I hedge my language because the language isn't really known yet, but it's one of the ideas, one of the possibilities suggested by the mathematics for the interior of a black hole. And the other thing, the final thing to say is that you might have heard about there's something called ER equals EPR. So that's Einstein-Rosen, which is wormholes, equals EPR, which is Einstein-Podolsky and Rosen. And EPR was a question about quantum mechanics and what Einstein calls spooky action at a distance, where you can have entangled quantum particles, and somehow it seems that if you do something to this one, then there's in a very real sense, this one's affected by it, but not in a way that you can transmit information, but it's quantum entanglement. And there is a picture where you can picture that as the two particles being connected by wormholes, and that was suggested by Leonard Susskind and others a few years ago. So that's called ER equals EPR. So wormholes are on the agenda in trying to understand what space and time are and how they behave. So they're not just science fiction. Would you like to be cryogenically frozen to experience the future? No, I think. I mean, first of all, we don't know how to do it, and we don't know if it's even possible to do. So you'd probably not survive. I wouldn't do it now. I wouldn't say, well, this is great, freeze my head. If you're thinking of doing that, then don't, because we don't think it's going to work. But at the moment, but if it became possible, it's kind of interesting, isn't it? Because I could ask you the question, because it would mean that you essentially stop living now. So everybody that you know and everything that you know about is gone forever. And then you wake up like 500 years in the future. What's your favourite mind-blowing fact? I think there's a lot. I mean, from the area that I work in a bit in research is black holes. And I still think it's mind-blowing that according to Einstein's theory alone, time ends inside a black hole. So the singularity is correctly thought of as a moment in time and the end of time. Whether that's the case is it depends on understanding of quantum gravity that we don't have. The fact that black holes exist, I think, the gravitationally completely collapsed objects that distort space and time so much that even light can't escape once it crosses into the interior of the black hole, if indeed the black hole has an interior. We're even arguing about that these days. So I think black holes exist, is my favourite fact. What's the scariest place in our solar system? The worst place for us, almost all of it, actually, beyond Earth, is horrible for us. It's almost like where is somewhere that isn't scary, because we couldn't exist. We couldn't exist anywhere unprotected, anywhere from, about 35,000 feet upwards or less, right? From the top of Everest upwards. We could, and then if you go underneath the water, right? So for us, if you go just a little bit down in the earth or a little bit up, there's a narrow band which is not scary for us, and everywhere else is horrible. Amongst the worst places are the sun, right? The sun's really not very nice. No, all of it. It's all absolutely terrible. Apart from a thin band where we live. Prove that the moon landings are real. You just look at any photograph taken by modern spacecraft, for example, which are not American spacecraft, if you want to be really conspiratorial about it. We have photographs of the landing sites with the stuff there. And I've met several of the people that walked on the moon. I've been very lucky to do so. And they are undoubtedly not bullshitters. And you've seen the video of Buzz Aldrin punching someone who said otherwise, and I fully supported him in that endeavour. How many galaxies are there? In the bit we can see of the universe, let's say 1 trillion, and you'll see different numbers. Because it's hard to measure, actually. So we're making estimates based on little bits of the sky that we can observe. It's billions and billions and billions, to paraphrase Carl Sagan. And it's something like, you could say 300 billion, 500 billion, 1 trillion, even 2 trillion. So within a factor of 2, 3 or 4, we're not really sure. It's an estimate because you can't count them. It's an exercise for everybody who's listening. Count to 1 trillion and then come back to me when you've done it. That's a lot, right? Which physics conspiracy theory really riles me up, or you up? I think it is the flat Earth, because it's just bizarre. The moon landing stuff is bizarre enough, but the flat Earth thing requires almost everybody who's sensible in the world to be part of a conspiracy, and just a small number of people who, in my view, appear to be a bit odd, to be the only people who know the truth. So the idea that everybody who's kind of flies a plane or does science or does anything at all is like we've all the clever people have got together to invent something that for no reason at all is just, I don't know why that would be the case. Favourite scientist? Oh, it's so easy to say. It's so easy to say someone like Einstein, isn't it? I like scientists that have made a massive contribution that we haven't heard of. So one, which I was lecturing about the other day and talking about, is there's a scientist called Emmy Noether. And Noether, Einstein described as one of the greatest mathematicians in history that many people have never heard of. And Emmy Noether, what she did was she showed the relationship between what we call symmetries of space. So the fact that the laws of nature are the same now and will be the same in 2 seconds' time. Right? So that's a symmetry in time. That's related to the conservation of energy. And she showed that the fact that if you do an experiment here and here, then you get the same outcome. The laws of nature are the same, is related to something called the conservation of momentum. It's like the recoil of a rifle and so on. So that was brilliant. And so she's one of my favourite scientists because not many people have heard of her, but it's massively influential. What stops atoms mixing? Like, how do they know to mix with the right things? Well, we talk about chemistry, so they don't know how to do anything. But for example, if you have carbon, then it's got 4 electrons around it, which would like to pair up with other electrons. So hydrogen would be a good thing. That has 1 electron that would like to pair up as well. So you can stick 4 hydrogens onto the carbon and you make methane. How should we balance investment in space exploration with addressing problems on Earth? I was involved in a discussion yesterday, actually. It was really interesting. And one of the experts in the space economy said to me that really we shouldn't think of the space economy as space. We should think of it as the economy. And so because it's not far, right? It's just 100 miles up there. So it's about we're in London now, so it's about the distance from London to Birmingham. If you go from London to Birmingham, but you go that way, you end up somewhere where you can do stuff that is useful, and it can produce economic growth. It can produce things like interesting drugs, for example, medicines and things which are not easy to build on Earth and so on. So you should think of space now, not as a thing, a separate thing, but as a place where there's an opportunity to do stuff that benefits us all here on Earth, and that's the challenge.
And Brian, we've got about 10 minutes left, so I don't know if you want to choose some of your favourite questions.
Why don't I go really fast?
Go really fast? Oh, great.
All right, we've got 10 minutes left. I'm going to go really fast.
Really fast.
What's the most significant scientific discovery in history? I would say, oh, no, I'm never going to be able to do this. I would say that it's possible to describe the world rationally, which is the foundation of modern science. So you could say Newton's law of gravity is the first modern scientific theory, but it's that idea that you can describe the world rationally. Favourite creature on Earth? Human beings. Will AI destroy us all? No. Probably. How realistically could the world end tomorrow? The most realistic way that the world could end is that someone presses the nuclear button. Do you believe in a creator? No, but I am not the sort of person that gets very upset if people do, because we don't know how the universe began or even if the universe had a beginning. What do I believe is in Area 51? Having driven around Nevada, I would say sand. Do you prefer being a physicist or the keyboardist in DREAM? A physicist? Definitely. Things have got better. Are we really from stars? Yes. So everything that isn't hydrogen in our bodies was made in the hearts of stars. Can infinity be measured? No, because it's infinite. Favourite alien from a film? Definitely Alien. Because it was one of my favourite. I saw Alien, right? The film, the original film. I saw it at a school film club in 1979. So that just tells you how the world has changed. Because I was 11, and they were going, "This is good. We'll sit there and we'll show Alien to all the 11-year-olds." I fully approve of that. What scares you? I've said it before, but it's humans. It's the fact that we might not survive long enough to become effectively immortal as a civilization and become a multiplanetary interstellar species. What could happen to a human in space without a spacesuit? You'd die. What the hell is string theory? It's a theory of the underlying structure of the world, which is based on little things which are very small, which probably exist in 10 dimensions. Are you sick of talking about space? No. Biggest fear for the future of humanity, that we don't have one because of our own stupidity. Do we live in a simulation? It's possible. Don't know. Yeah, you want me to say more about that, didn't you? What's a solar storm and why is it dangerous to the Earth? Solar storms are potentially dangerous to the Earth. It's when the sun, essentially the magnetic field of the sun reconfigures itself such that stuff is ejected out into space. And it can be very damaging, not to the Earth really, but to our systems, power systems and so on, and satellites. So it can cause trouble. What is something scientific that you could have died happy not knowing? Have you seen The Last of Us? Right. Because, mushrooms take over ants. So, I don't want the mushrooms to take over people. Is space travel ethical? Yes, I think it's more than that. It's essential. And we use it every day, of course, with GPS and so on. Which person would you least want to be trapped in a rocket with? There's quite a few. There you go. If you could choose one event in the universe's history to witness, what would it be? You know what? I'd like to see the origin of life on Earth. And that's weird because it's probably not an event, is it? But, I'd like to be able to go back and see how this all began.